This next module expands your RESTconf skills by moving away from pure Python and into a popular configuration management tool called Ansible. You should already know a bit about Ansible as it was covered in a previous course. When I discussed Ansible earlier, it was in the context of web servers. This time, we'll use Ansible plus RESTconf to manage Cisco IOS XE routers. Like the previous module, we'll spend almost all of our time on demos. I'll teach you how to use Ansible to collect, add, and delete interfaces from the router. We'll follow a similar flow here, much like what we did previously using 3 separate efforts to keep things simple. Last, we'll finish up by repeating the collect, add, delete process for VLANs on Cisco IOS XE. Both the interface and VLAN efforts include Yang tree analysis as well. Let's begin with a quick refresher on how Ansible works at a high level before we dive into a ton of examples. Ansible was the first commercial-grade automation framework I deployed in production, and I loved it. Because there are no agents, the architecture is quite simple. The control machine is what manages the infrastructure devices under Ansible's control. Ansible traditionally uses SSH to manage both servers and network devices, but these days it can use SNMP, netconf, RESTconf, and more. Our demos will use RESTconf, but I feel like depicting SSH is a little easier. Ansible logic is broken into 3 building blocks known as playbooks, plays, and tasks. Much like in sports, a playbook is a collection of plays. Each play identifies a group of managed devices that are to be acted upon in some way. The specific actions within a play that are run against these hosts are called tasks. Ansible playbooks are written in YAML, while Ansible itself is written in Python, and the Ansible domain-specific language is pretty easy to read. This playbook has 2 tasks. The first task logs into every device in the router's group and issues the show run command. This collects the full configuration from each router. The second task displays the configuration data just collected. As a final point, I published a deep dive course covering Ansible for network automation here at Pluralsight. If you're a network engineer interested in automation, you should check it out. It covers a variety of SSH-based approaches as well as netconf and RESTconf. In addition to playbooks, there are a few auxiliary components to consider within Ansible. The inventory is a collection of all the hosts Ansible should manage. In simple deployments, this is usually a local file that statically defines hostnames or IP addresses. Larger deployments may tie into a database using a dynamic inventory plugin. We'll keep it simple using a local file in our demos today. The Ansible inventory supports hierarchical device organization using groups, and if you recall, individual plays in a playbook will execute tasks against these groups. We can also define variables in Ansible. These can be host-specific, group-specific, task-specific, play-specific, and many more. We'll be using variables to identify configuration updates, both additions and deletions, in our demos. We can also specify connectivity variables like login credentials and transport methods such as netconf, RESTconf, or SSH. Last, there is an administrative configuration file which tells Ansible how to operate at a global level. For example, it tells Ansible where to find the inventory file and Python modules, as well as logging options. Before digging into Ansible with RESTconf, we need to explore the relevant Yang model first. We'll do that in the next clip.